For this lesson, linear inequalities and two variables, you have to remember how to graph inequalities on a regular number line, and you can transfer that information to graphing on the coordinate plane. You have to know how to originally plot, have to know how to plot functions on the coordinate plane. That's the first thing you want to know how to do. And then you have to remember, when do I have a solid line? So let's just do a quick review. So right here we have a solid line. So you want to use a solid line when you have the greater than or equal to or less than or equal to inequality. So remember, if you were graphing, you want to include the shading because the number is included in the solution because you have the or equal to line underneath. So that's when you want that solid line, no dashes, no missing spaces. Over here in this graph, we have a dash line, and you want to use the dash line when you have the less than or when you have the greater than signs because the number is not included in the solution. Okay, so that's just a little quick reminder from 6th grade, and you can apply that information. So then you want to think about, okay, how do I know which way to shade? So if we look at this equation over here, it says that y must be greater than or equal to. So if we just focus on that key component, y, the fact that it's greater than or equal to says that we need a solid line. So my line is solid, no dashes, it's a solid line. And then it says y needs to be greater. So since y needs to be higher, I'm going to shade above that line. And that's how you do the shading. Now this one over here says y needs to be less than. So since it's not less than or equal to, I know I need a dash line, which is why you see spaces because the number or the function is not included in the solution. So now we have y is lower than, y is less than. So you will shade lower on y instead of greater than. And that's pretty much the lesson. So you have to connect a lot of things that you've learned in the past to apply it towards this lesson. We're going to look at an example now, look at a few examples. So here's the first example when you only have an x coordinate. So this one says that x is greater than or equal to 3. So remember, we want the values for x, or the values that you can substitute in for x, need to be greater than or equal to. So if you remember from previous learning in 6th grade and in 7th grade, you had a closed circle on 3 showing that 3 was included in a solution. And then you shaded to the right showing that x can be all values that's greater than or equal to 3. So we want to transfer that same information to a graph. So you would say, okay, x, my value for x is always going to be greater than 3. So your value for x is always going to be 3. So that's why we put a line on 3. And then it says greater than or equal to, so that's why we will shade to the right along the x, showing that x can be 4, 5, 6, 7, and so forth. All right, so here's another example. We have y is less than 2. So because y is less than 2, you have to have a dash line showing that that 2 is not included in the solution, right? So if I were to graph this on an inequality or on a number line, I would have 2, 3, 4, 1, 0, -1. I would have a open circle on 2 showing that 2 is not included in the solution, and then I want values that's less, so I will shade to the left. Okay, this is a number line, and they did a vertical right here because your y-axis is vertical. So since it's less than, you will shade to the lower. So right here we have a dashed line showing that 2 is not included in the solution. And then we want to shade lower because y is less than. Now, if y was greater than, then you would shade above that line. But since y is less than, you want to shade below the line. Here is an example. What is the solution of the inequality? Y is less than or equal to x minus 1. So because I already have y on one side of the equal sign, or one side of the inequality by itself, I'm going to go ahead and graph my function. So I'm going to start at my origin 0, 0. Since my y-intercept is -1, I'm going to go down to -1 and plot my first point. And then my slope is +1. So remember, slope is rise over run. The coefficient that's in front of the x is 1. And if I change 1 into a fraction, it'll be 1 over 1. So I'm going to rise and run 1 and make sure the top of my line is in a positive direction, showing that my slope is positive. And then I'm going to graph my line. So now that I have my line graphed, I want to go ahead and graph the possible values for y. So it says y is less than or equal to. So since y is less than or equal to, I'm going to shade lower along the y-axis, which will look like this. So everywhere underneath that line and underneath that function that I just graphed, I will shade. And then that's what you will submit for this example. All right, so now we want to look at what inequalities does the graph show. So if we look here, we know it's going to be an inequality because we have shading and we have dashed line. So remember, when you have a dashed line, that's showing that the number is not included in the solution. So we need the less than or greater than inequality. It's going to be one of the two. Our y-intercept, where our line passes through the y-axis, is 0. So I know it's going to be plus 0 on the end. And then I'm going to figure out what is my slope. So if I'm rising, I'm going to find another point on the line. So about right here. So I'm rising 1. So that's going to be my rise. Slope is rise over run. I'm rising 1 and I'm running 1, 2, 3. So 1/3 is going to be my slope, and I'm just going to check it with another point. Rising 1 and running 1, 2, 3. So that's going to be my slope. So it's going to be y, and since we shaded lower than the line, y is going to be less than, right? Because I shaded below y, so it's going to be less than 1/3 times x plus 0. Or another way you can just write it is y is less than 1/3 times x, and that's the final answer. Okay, let's look at another one. We want to come up with the inequality for this graph. So this is a solid line. Since we have a solid line, the number is included in the solution.